Hello all, welcome to iTutor Academy. In today's session, we will start with Unit 16, that is time series analysis. So let's see the objectives of this chapter. After completion of this unit, you should be able to appreciate the role of time series analysis in short-term forecasting, decompose a time series into its various components, understand autocorrelation to help identify the underlying patterns of a time series, become aware of stochastic and model developed by Box and Jenkins for the time series analysis, make forecast from historical data using suitable choice from available method. And structure of these units are: there is an introduction part, decomposition method, example of forecasting using decomposition, use of autocorrelation in identifying time series, and outline Box Jenkins model for time series. Summary is there, self-assessment exercise keywords are there. And start with an introduction. Time series analysis is one of the most powerful method in use, especially for short-term forecasting purpose. From the historical data, one attempt to obtain the underlying pattern so that the suitable model of the process can be developed, which is then used for purposes of forecasting or studying the internal structure of the process as a whole. We have already seen in earlier unit that a variety of methods such as subjective method, moving average and exponential smoothing, regression method, causal model and time series analysis are available for forecasting. Time series analysis looks for the dependence between value in a time series, a set of values recorded at equal time interval with a view to accurately identify the underlying pattern of the data. In the case of quantitative method of forecasting, each technique makes explicit assumption about the underlying pattern. For instance, in using regression model, we had first to make a guess on whether a linear or parabolic model should be chosen, and only then could we proceed with the estimation of parameters and model development. We could rely on mere visual inspection of the data or its graphical plot to make the best choice of the underlying model. However, such a guesswork, though not uncommon, is unlikely to yield very accurate or reliable results. In time series analysis, a systematic attempt is made to identify and isolate different kind of patterns in the data. The four kind of patterns that are most frequently encountered are horizontal, non-stationary, that is trend or growth, seasonal and cyclical, that is generally a random or noise component is also superimposed. We shall first examine the method of decomposition wherein a model of the time series in terms of this pattern can be developed. This can then be used for forecasting purposes as illustrated through an example. A more accurate and statistically sound procedure to identify the patterns in a time series is through the use of autocorrelations. Autocorrelation refers to the correlation between the same variable at different time lags and was discussed in Unit 18. Autocorrelation can be used to identify the pattern in a time series and biggest appropriate stochastic and the model for this underlying process. A brief outline of common process and the Box-Jenkins methodology is there given. And finally, the question of the choice of forecasting method is taken up. Characteristics of various methods are summarized along with the likely situation where these may be applied. Of course, the consideration of cost and accuracy decided in the forecast play a very important role in the choice. Next is decomposition method. Economic or business oriented time series are made up of four component trend, that is seasonality, cycle and randomness, and further it is usually assumed that the relationship between these four components is multiplicative as shown in the equation. Okay, so this is the xt is equal to tt plus st plus ct plus rt. Okay, so what is xt? The observed value of the time series. Tt denoted the trend, st denote the seasonality, ct denote the cycle, rt denote the randomness. Okay, so this is the equation. And but additive model are not commonly encountered in practice. We shall therefore be working with a model of the form and shall systematically try to identify the individual components. You are already familiar with the concept of moving average. If the time series represent a seasonal pattern of L period, then by taking a moving average of L period, we would get the mean value for the year, and such a value will obviously be free of seasonal effect, and since high months will be offset by low ones. If MT denotes the moving average of equation, it will be free of seasonality and will contain little randomness. And the trend and cycle components in equation can be further decomposed by assuming some form of trend. That is, one could assume different kind of trends, such as linear trend, which implies a constant rate of change, and here is figure 1, linear trend, and parabolic trend, that is which implies a varying rate of change, and exponential or logarithmic trend, which implies a constant percentage rate of change, that is figure 3, and S curve, which implies slow initial growth with increasing rate of growth followed by a declining growth rate and eventual saturation. So this is linear trend, parabolic trend is here, and exponential trend is here. A typical S curve also here. Knowing the pattern of the trend, the appropriate mathematical function could be determined from the data by using the method of regression as outlined in earlier unit. This would establish the value of parameter of the chosen trend, and example also here. And finally, the randomness can be eliminated by average the different value of equation, that is averaging is done on the same months or season of different years. Okay, and the result is set of seasonal value free of randomness called seasonal indices, and which are widely used in practice. Next is example of forecasting using decomposition. An engineering firm produced farm equipment want to predict further future sales based on the analysis of its past sales pattern. The sales of the company for the last 5 years are given in table, that is quarterly states of an engineering firm during 1983. This is the table, and procedure involved in the study consists of, here is A, B, C, D are there, and deseasonalizing time series, and the computation of moving average, that is MT, and the ration XT divided by MT. And this is the table. It should be noticed that the 4 quarters moving total pertain to the middle of 2 successive periods is here, and computation of seasonal indices are here. Table 4 is a deseasonalized sales are here. Okay, so our example, you just go through with this example from your IGNOU study material MMBC005 unit 16. Fitting a trend line is here, and the table also computation of trend is here, and this is identifying the cyclical variation. The cyclical component is identified by measuring deseasonalized variation around the trend line as the ratio of the actual deseasonalized sales to the value predicted by the trend line. Computation of cyclical variation is here, and the time series with the trend and moving average, and forecasting with the decomposed component of the time series. And use of autocorrelation in identifying the time series. While studying correlation in unit, autocorrelation was defined as the correlation of a variable with itself but with a time lag. The study of autocorrelation provides very valuable clues to the underlying pattern of the time series. It can also be used to estimate the length of the season for seasonality. And this is from use of autocorrelation in identifying the time series. The estimate have been obtained by taking the trend and the seasonal variation into account, and cyclical and irregular component have not been taken into account. The procedure of cyclical variation only help to study the behavior and does not help in predicting the future behavior. So moreover, the random irregular variation are difficult to quantify. Okay, so this is about today's session, and the next section of use of autocorrelation we will discuss on further videos. For more IGNOU MBA videos, you just do like, share and subscribe our channel, and thank you for your support.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students. semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.